Welcome to This Explainer. Today, we are taking a really deep dive into the hidden mechanics of the web. Together, we're going to systematically peel back the layers of web development, moving all the way from foundational architecture right up to the modern trends that are completely reshaping how we interact with the digital world today. So, whether you're a seasoned developer or just endlessly curious about how things work, get ready to see the internet in a completely new light. Okay, let's dive right into this by posing a deceptively simple question. What really happens when you click a button on the web? Think about it for a second. You click like, you hit submit, or you refresh a feed. On the surface, it's instantaneous, right? But beneath that single click is a massive, highly orchestrated journey of data traveling from the visible surface down to the server level and back again. And that hidden journey is exactly what we are mapping out today. To make this whole journey easy to digest, here's our structured path for today. 1. The web development iceberg. 2. Decoding the mern stack. 3. The app development lifecycle. 4. Architecture, building the web. 5. Modern web paradigms. And finally, 6. Inspecting the hidden web. Let's get started. We'll kick things off with section 1, the web development iceberg, looking at front end versus back end. Think of web development as having two main hemispheres. On one side, you have the front end, or the client side. This is literally everything you, the user, interact with. If you love that sleek, translucent glass aesthetic on modern iOS apps or Google's super clean material design, well, this is where that magic happens. It's all built with HTML, CSS, JavaScript, and libraries like React. But over on the other side is the back end, the server side. This is where the heavy lifting happens, the databases, the Ubuntu servers, and all the application logic that actually handles your passwords and processes the data. It's honestly exactly like a giant iceberg. The front end, what you actually see, is just that tiny fraction sticking out above the water. But supporting all of that is a massive, unseen back end. And right there in the middle, you have the full-stack developer. The crucial takeaway here is that a full-stack developer acts as the bridge, connecting those deep database waters directly to the user's screen to ensure a totally seamless flow of data from bottom to top. Moving on to section 2, decoding the mern stack and the JavaScript ecosystem. So mern is an acronym for an absolute powerhouse combination of technologies. We kick things off with MongoDB, which is a NoSQL database that's perfect for handling flexible, complex data. Next is Express.js, a really minimal backend routing framework. Then we've got React, the highly efficient front-end UI library. And finally, Node.js, which is the runtime environment that actually allows JavaScript to run outside of the web browser. So you might be wondering, why is this specific combination in such immense global demand? Well, its superpower is unifying the language. By using JavaScript end-to-end, developers don't have to constantly context switch between languages, like using Python on the back end and JavaScript on the front end. It is just incredibly efficient for building complex, data-heavy systems. Think of something like a secure university portal that tracks attendance and logs grades. Now, mastering the mern stack doesn't happen overnight, for sure. There is a pretty comprehensive 8-step roadmap to actually achieving full-stack mastery. You have to start with the internet fundamentals, like HTTP and DNS, then master the HTML and CSS basics, and learn a framework like React. After that, you secure your code with version control using Git, dive into backend development and database management, implement robust security like JSON Web Tokens, and finally tackle deployment using tools like Docker and Ubuntu servers. It's a journey, absolutely, but a highly rewarding one. Which brings us to section 3, the app development lifecycle, from the initial plan all the way to maintenance. Building a robust application is definitely not a straight line. It's actually a strict cyclical process following an agile lifecycle model. You always begin with planning and defining the scope. Then you move into UI and UX design for wireframing, and then on to development where the actual coding happens. From there, it requires rigorous testing to ensure quality, and then finally deployment to a live production environment. But notice how it forms a circle. Pushing to a live environment is really just one step. After deployment comes maintenance, monitoring bugs, updating dependencies, and building new features, which leads right back to planning again. Next up is section 4, building the web, where we get into web architecture. The most foundational choice a developer makes is between static and dynamic sites. Static websites are basically just hard-coded HTML and CSS. They simply sit there, unchanging, exactly the same for every single visitor, unless a developer manually goes in and edits the file. Dynamic websites, on the other hand, are connected to databases. They assemble the web page on the fly. This is what enables personalization, like a social media feed tailored just to you. A true web application like Figma or Google Docs heavily emphasizes this dynamic interaction over just passively consuming information. You don't just read it, you create, modify, and delete data. And how those dynamic apps actually load has evolved drastically over the years. We used to rely entirely on multi-page applications, or MPAs. In an MPA, every single time you click a link or navigate to a new section, the browser completely reloads, fetching a brand new, fully constructed HTML page from the server. It can feel, well, a bit clunky. Today, modern development, powered by tools like React, heavily favors the single-page application, or SPA. With an SPA, the browser loads just one initial HTML file. Then, when you click around, JavaScript dynamically rewrites the current page. It feels instantly responsive, mimicking the speed and feel of a native mobile app. It's all about that silent efficiency. With the traditional MPA, you're forcing a full reload, requesting heavy HTML every single time you do anything. But the SPA elegantly maintains the main app shell on your screen. It silently fetches lightweight JSON data in the background and instantly updates the UI without a single visual reload. To wrap up the whole architecture piece, developers also have to choose where the heavy lifting of rendering actually happens. With client-side rendering, the server sends a bare-bones HTML file along with a massive JavaScript file, basically forcing your browser to do the work and construct the UI. It's incredibly fast once it's loaded, but that initial load can be a bit slow, and search engines really struggle to read it. Conversely, with server-side rendering, the server executes the code and sends a fully finished, populated HTML page directly to the browser. This strategy guarantees incredibly fast initial page loads and gives you excellent search engine optimization. Let's look ahead in Section 5, Modern Web Paradigms and the Future of Web Dev. One absolutely massive shift right now is toward the Jamstack architecture. Jamstack literally stands for JavaScript, APIs, and markup. Instead of relying on a traditional server to generate pages on the fly every time they're requested, Jamstack pre-builds the entire website into static HTML files during the deployment phase. Those files are then served instantly from a global content delivery network. Any dynamic functionality that's just handled by client-side JavaScript talking to third-party APIs. It makes the web incredibly fast and exceptionally secure by removing the traditional server from the equation entirely. Next up, we have progressive web apps, or PWAs, which completely blur the line between a standard website and a native app on your phone. By utilizing modern browser capabilities and background scripts called service workers, PWAs can cache files so they function even when you are completely offline. You can actually install a PWA directly to your smartphone's home screen without ever visiting an app store, complete with a custom icon and the ability to receive push notifications. Pretty cool, right? And of course, there's the paradigm shift of Web 3. The decentralized web. While traditional Web 2 relies on centralized servers owned by giant tech corporations, Web 3 distributes back-end logic, which are known as smart contracts, alongside data across a decentralized blockchain network. So instead of logging in with a standard username and password on a corporate database, you actually interact with these decentralized apps using a cryptographic digital wallet. But perhaps the most explosive frontier right now is AI-powered web apps. Developers are seamlessly integrating artificial intelligence directly into web platforms by passing user inputs via APIs to large language models like Gemini. We are rapidly moving beyond static interfaces. Today's web apps are beginning to function as highly capable digital intelligence agents, dynamically generating personalized UI layouts on the fly, auto-summarizing massive datasets, and acting as highly conscious conversational assistants right there in your browser. Finally, let's get hands-on in Section 6, inspecting the web and uncovering that hidden network. I really want to encourage you to actively try this out with us. Grab your metaphorical developer tools. If you are on a computer right now, open up a complex web application, something highly interactive like Twitter, your email, or your university student portal. We're actually going to intercept the data before the front end makes it pretty. Okay, here is your practical exercise. First, pop open your developer tools. Usually, you do this by hitting F12 or right-clicking and selecting Inspect. Second, navigate over to the Network tab at the top of that panel and make sure the Fetch/XHR filter is selected. Third, interact with the page. Click a like button or navigate to a new section. You will immediately see new entries popping up in that panel. That is literally you observing the hidden background requests of the single-page app architecture, asking the server for data. Finally, click on one of those entries and look at the Preview or Response tab. You are now looking at the raw API data, formatted in JSON, right at the source, completely stripped of its visual interface. So you now possess the ability to look right beneath the surface of that web development iceberg we talked about earlier.
But I want to leave you with a provocative thought. Today, we look at JSON data flowing between a client and a centralized server. But as decentralized Web3 smart contracts and highly conscious AI agents continue to evolve and take over web platforms, how will those hidden network payloads you just learned to inspect change tomorrow? The architecture of the web is never static, and the next evolution is already underway. Thanks for joining me on this explainer. Keep exploring, keep inspecting, and definitely stay curious.